Hello everyone, thanks for joining for another video session from the Distech Controls OEM team. My name is Ham Donishman. I'm the Director of OEM Sales for Distech Controls. I'm very excited to talk about a brand new product that we are just releasing, and we actually did release it during our ASHRAE AHR show this past couple of weeks ago. And the name of the product is the Smart Air Control Valve. And we are very excited about this product due to the fact that we truly believe this is a disruptive type of technology that is going to be introduced in the HVAC market, which I will be explaining that to you today in this hopefully a short video. So again, thanks for joining, and let's get right to it. So one thing I want to make sure that everybody understands that Distech Controls has been developing products for over 25 years. And one of the concepts that we continue to strive on, three concepts is really, which I would like everyone to take away from, that Distech Controls is always about open platform, flexibility around products that we design and we introduce into the market, and around innovation. We're always are forward thinking, and we want to make sure that we introduce products in the industry that obviously it's at the edge of the market, and it's being introduced in a sense that we are here to disrupt the market space, and we're providing products that are not only is very efficient and is doing everything it can from efficiencies and energy savings, but it is a product that is not just for today, but it is for the future. And it's all about innovation and products that we have been developing now for past 20 some odd years. So just really quick, just to describe for past 3 years or so where we're heading or where we started. We started around our Eclipse product line. Our Eclipse product line has been around since 2016. That's when it was introduced. We were the first IP platform from a backnet IP that was introduced into the market space. And we have continuously have improved that product line as of right now in 2022. And then some of the newer excitement things that happened within the last 3 years is more around the cloud connectivity, is what we call cloud relay to Microsoft Azure platform. And then also our brand new Eclipse thermostat that was introduced about 6 months ago. Our Apex controller, which is our brand new controller that is a tip of the technology, is a truly an IoT edge device technology that is will be used within our Eclipse family of product. It is definitely the highest and the most powerful product controller that we have introduced, and is definitely the most powerful controller within the industry with lots of features around IoT. Today we're going to be talking about the Smart Air Valve, the Eclipse Smart Air Valve, which is a disruptive new technology from a traditional VAV market space. And that's what we're going to talk about today. If you think about what the VAV system has been around for 40 some odd years, since really 1970s, from a mechanical system design, the characteristics really has not changed. And we went from a shift from pneumatic to DDC. That was really the only shift that happened in the mid 80s. If you think about the VAV system and the engineers that are actually designing these products, there's a very complex process from start to finish. When you're talking about the number of SKUs that you have to have based on different sizes, you have to worry about your primary set of equipment as far as the amount of air that is being moved throughout the space, and based on pressure, based on different sizing, and obviously the temperature that you're controlling in that space. Excuse me. The other aspect of the VAV system, which is as a part of the workflow that's involved, is really balancing the system. And that is a major task that has to happen throughout every single building. Doesn't matter if it's a small 10,000 square foot building all the way up to a complex set of buildings that are out there. It's always about you have to balance the system and make sure it is based on the specific of the design of the primary set of equipment that's been introduced into the building. So that's always been a challenge, and that's always been part of the workflow. There's always also been an accurate flow measurements, and that is really where this new disruptive product is going to make a change. And that is really talking about around when you're on the lower part of the CFM and you're trying to manage the building when it's in an unoccupied space time frame, and you're really truly going after the ASHRAE standards that tells you when you're in that unoccupied time and you need to drive that CFM down to, let's say, a 50 CFM or even below, there's not a single VAV system or VAV product out there today that can do that. So one of the key features and value proposition around this product is that, and that's what I'm going to be showing you today and demoing that to you. And then continuing with some of the other aspects about the traditional VAV system, it's really about talking about the cost of not only from the energy consumption, the installation, the amount of noise that's being generated within the VAV system that you have to be concerned about, and then really the number of SKUs that we talked about and the engineering time, the workflow that it takes to really do the installation. And one thing that I haven't really mentioned even on the slide here, when you install a VAV system, and what happens if there's a retrofit happens for that owner that wants to maybe move the walls around, change the design. What happens today, basically, you almost have to redo your entire equipment HVAC design, change your ductwork based on the pressure. All of that gets changed. You have to go through and rebalance the system. With this new product, that's not the case anymore, and I will talk about that. And that's the terminology around flex spaces. If you look at the market analysis, the VAV market space it's definitely growing, and it can continue to grow. It's about a 6.3% CAGR throughout the year up to 2026, and really is focused around complex buildings, even in the retail business, warehouses, other office spaces. VAV does reside and is part of the design that's in the system. So the growth of the market is very healthy and is continuing to grow, especially in North America. Disruptive technology. So this is really what I'm going to talk and kind of geek out a little bit here. Sorry about my terminology there. But the product is that we have designed collaboration with our manufacturer. It's all about math. And this is really to truly solve a complex fluid dynamic problem. And having that accurate flow measurement that is needed over a wide dynamic range at the economical price point, which is very important in our industry. So what happened is, we had, working with our HVAC manufacturing group, we worked with that group, and they went back with a couple of their scientists and went back in time, actually. In 1643, there's a theorem that was discovered by the Torsellis, and it was called the Vienna Contracta. And that theorem has been in place since 1643, and it was about this exact problem, which is the fluid stream, and trying to figure out where the accuracy are and how can you be able to accurately measure the amount of velocity that goes through that basically a diameter of the orifice that you're trying to measure to. So in this case would be such as in the case of a stream issuing out of a nozzle, like an orifice. So this is all about math. So new equations were invented by these two PhD people from MIT, and they were able to solve this problem and really looking at it as single size damper and then mimic that performance to a several calibrated orifices or the wide range of dynamic range of the which basically had to do with the economic side of it with a single transducer. Most controllers out there come with a single transducer, and that's where the efficiency comes from. And we had to solve that problem with that particular transducer. And then having that accurate measurement around the Vienna Contracta, which is basically is in the turbulence zone. And that turbulence zone is when you close a damper, and then now you have more turbulences happen, that's what you're trying to drive to in the lower CFM. And that's where the accuracy becomes very important. Traditional VAV boxes, the reason you have so many different sizes from 4-inch all the way up to 26, 28 inches, depending on round or whatever the rectangular size you may have, driving that to get to that lower CFM with an accurate reading. When you were below that 150 CFM, typically you're bouncing all over the place, and that's really the key when it comes to this technology. Several patents has been pending and has been issued on this particular product. As far as manufacturing, we have, again, collaboration with a company called HVAC Manufacturing. We're working with those guys, and they are have a very innovative center around R&D, automated type of sheet metal fabrication, piping fabrication, automated production line. They're actually a UL 508H panel shop, which we'll talk about that a little bit later. And they have a center of excellence team with the best-in-class flow stands that are ready to do all the calibrations necessary for the different sizes of these smart air valves that we're going to be discussing here. If I do a competitive comparison, and I'm not going to go through a whole lot of details here, I talked about the different sizes, and the reason you have these different sizes is trying to get to the accuracies that are needed for the different applications and the different building sizes. So lots of different competitors are out there. If you look at the Disruptive Control SACV, now we're only, instead of talking about all these different sizes, we're only talking about only 4 sizes. Currently, only 4 sizes. I want to repeat that again. There's only 4 sizes. We're talking about a 12-inch and a 16-inch round, and a 10 by 15 and a 10 by 21 rectangular size. So if you really look at that, and we do have reheat options with these as far as coil, electric is part of that package as well. And if you look at that, we are looking at around a plus or minus 3% accuracy at 200 FPM to 2500 FPM. And when you go below that to around 25 FPM to 200 FPM, we're at a plus or minus 8%. And we're talking about minimum low pressures of 0.03 inches at 25 CFM. And our turn down ratio, the reason we only have 4 sizes is truly because of this turn down ratio at 300 to 1. If you compare that to your traditional VAV boxes out there today, they are at 4 to 1. That is the game changer. That is what makes this product what we're talking about disruptive in this space. And this is what's going to, to be honest, I really compare this when Uber came out and really disrupt the whole taxi business. And now everybody's using Uber, just about anybody right now that you go out there and use Uber. This is disruptive to that similar market space. If I have to do a comparison here, this is what I compare that to. Now, if I look at more of a lab type of environment, this product is definitely flexible and it is accurate enough to be in a lab environment. So even if I look at some of the Venturic valves market competitive that are out there today, our numbers are equivalent or even better even on the existing products that are in the lab environment. So even though we have a smart air control valve coming out from a VAV type of commercial VAV type of applications, we will be working on a second phase, which is not that far off. We're only talking about maybe 2 to 3 months down the road, and which will be in the mid range, or late spring to early summer of 2022, that we will have a lab version of this as well, which would be with a faster actuator. Instead of your typical 90-second actuator, it would be around 3 to 5 second actuating, and then it would be a higher accurate transducer, even though our current controller that we're using, which is part of the DISTEC Eclipse VAV controller, that product, the transducer that's on that product is very accurate today. But going into the lab environment, we do recognize that we need to even be more accurate, and then we also need a faster actuator to do so. This chart here should really recognize to a lot of people out there, especially in the mechanical world. So we're talking about, this is a simple example from a Kruger inlet system or CFM in a single graph. So if you look at everything on the left-hand side from a 4-inch all the way up to 22-inch, your typical market CFM size is from 7 to 22 inches. And then you can see if you go down to the right, the range actually from a pressure and then the amount of CFM, the reason you have those many sizes is to be able to get the accuracy and the amount of CFM that you would need in a space. What we're saying with this product, we could go down to 0.01 to 0.03 of your pressure that's you need within the space, and then we could go all the way up to over 2,000 CFM with only one product, which is 12-inch round product. So that is the disruptive again. So from a 12-inch. So now if I put the 16-inch, now I cover everything else above that as well. So 2 parts and then 2 rectangular that covers the entire range of all the different sizes that are out there. From value proposition, we could talk about as far as the precision flow measurement. Obviously, we talked about that. We have different types of options around stainless or galvanized steel for the different applications you may need based on healthcare, commercial, industrial. 301 turn down, that is the game changer. It is part of the whole algorithm that's running inside this controller and the design of the valve itself based on the OFIS and the way the air movement and the analytics that are running inside the controller itself. One size for all zones, yeah, it's pretty much true because we are talking about not that many sizes here. Obviously, 4 sizes, and you can always use transitions to transition down or up or what you need based on the ductwork that's in the space. Obviously, new construction, you're designing it from ground up. We do recognize we have been getting some feedback, especially in certain part of the country, especially if you're doing retrofit work, that there may not be that much space within your plenum area that we may need to get one more size into the picture, which would be around 8-inch. ASHRAE 195 compliant, which is very important to understand. If you don't know it, please read it. And that is when we're talking about the unoccupied type of compliance, which means you have to be at a certain CFM range to be in that unoccupancy and then be able to save the energy that's needed when you're in that unoccupied period. We can get there and we could be compliant to this ASHRAE standard. There's a lot of VAV boxes out there today from different competitors that cannot get to that range. And I'm talking about below 100 CFM. I'm talking about down to 50 CFM. I'm talking about down to 10 CFM. And those are the things that I will be demoing this live for the team here. The other thing to understand here, when it comes out of factory, this product is ready to go. It's arrive alive. And that really what happens within the disruption of this product is, I understand a lot of people bundle solutions. They put controller on a box, they send it out, but you still got to program it. You still got to do commissioning. You have to do the startup that's necessary for the box. In this case, you literally is as close as you can with a plug and play. And what we have here, this is a BACnet IP controller ready to go out of the box. It's configured. It has its commission paper ready to go. And when you get this out in the field, there is no balancing. Again, I'm going to say that. There is no balancing. There is no K factors. What you have in this product is all you have to enter, which you could do that through the stat or a balancing tool, is only add maximum CFM and minimum CFM. And I said balancing tool just because I'm a HVAC guy, controls guy. I've used that multiple times in my previous jobs, and I need to get rid of that term. But there is no balancing here. Superior acoustics, when you're driving to those low standards, and the shape and the product design it's basically we have very, very well designed around super acoustics. And then as far as the high performance with the slanted coils that we have installed within this product, slanted for cooling or heating, which kind of provides you the necessary things you would need from a humidification. Traditional construction process. Again, this is pretty important. If you think about typical VAV traditional construction process, you have your engineering selection that happens up front. You have to complete your documents and you provide it to your contractor. Then there's your contractor selection. Then you have to procure your VAV boxes. You have to submit for review. And then you have your controls procurement, which basically you're purchasing all your products. Then you have your control delivery VAV boxes. And then you have your VAV boxes delivery. Then you have your control startup. Then you have the balance of flow. And then you're turning the job over. That's typically your flow, which could be, obviously this flow could take up to 6 months to be able to get a VAV project up and running and finished. Could be longer. What we're proposing that the SACV time savings here is everything you see with one slash is basically saying there's a certain amount of work that has been eliminated. So document completion, we provide that up front. That's done. You still have to have engineering select. You still have to contractor selection. Your VAV box procurement is not needed anymore. You could actually select the boxes been pre-selected for you. You want a 12-inch, you get 12-inch, and then install 50 of them if you want. You don't have to worry about all these different sizes. Submittal review, obviously there's still a submittal review, but not as complicated as it was before. Controls procurement, there's still some controls procurement you have to do, obviously, but it comes as a bundle solution, pre-ready to go from the factory. You deliver the boxes, you don't have any kind of control startup, you don't have any kind of balancing type of startup and balancing work that needs to be done, and then you basically have reduced delivery time. That's another disruptive part of this whole new product industry introduction into the market. We already talked about this, the different sizes, 12, 16, 10 to 15, 10 to 21. We do have providing you regarding the hot water reheat is definitely included in this. We are coming out with the electric very soon, and those are just some of the solutions and as far as reviewing the product itself. So those things are still part of this from the selection of the box perspective, but the size when it comes to engineer, you're only looking at 4 different sizes right now. If I look at some of the value proposition again, we've talked about this already. Advanced software algorithm, which is built within our Eclipse controller from Disruptive Controls. We have very variable aspect ratio for retrofits and space constraint. We have a 300 to 101 turn down, 4% accuracy. It can basically have 2 pitot tubes or non-clogging orifice ring sensors that are part of this whole complete package. We have an ultra-low leak aerospace damper gasket, and as you can see, we have very other features around welded seam, IoT internal, 100x magnification, round or low profile, high accurate with feedback, and controller and transducer. Controller being at the end of this, that controller. The pictures you see there, that's the rectangular feature, the rectangular box, and then we also have the round box there. The other thing that is good to note here, that this particular bundle solution is not just about HVAC. The product itself, it's truly about a smart room controller or a smart room offering. So the Eclipse product is capable enough to not only do everything we talked about from a smart air control valve, but also has capability to tie into the lighting infrastructure and then also to the blind controls. Through our stat, that's what we call a Unitouch. You have a Bluetooth connectivity and you have a free app that you can use to be able to manage the system. So it is a fully completed system when you're talking about an automated room control. And then on top of that, this product is truly an IoT edge device as well, which I'll talk about that in a little bit. So this is, again, from a product solution review. All right, now it's time for a live demo, which I will do that right now. Okay, we are back. Checking to see if I'm started my recording. So I have logged into the smart air valve that is actually in my garage, and I am connected through our Wi-Fi through my home Wi-Fi, and I do have a Wi-Fi dongle on the controller itself that is on this particular device. And right now I'm getting live information. The fan is running. I do have a trend log here. We're running about a 34% fan speed. And the only reason there's a fan on this particular box, this is a demo box. So I obviously needed some sort of a fan for it to push some air through so I could show everyone the airflow, the set point, what is my pressure reading, what my actuator command is doing. So as you can see right now, I am actually running this device at set point of 3, and I'm actually at 3.7. So I'm only 0.7 CFM off from the actual set point. And this is right now showing you very low end, but I do want to make sure that you understand this is not magic. And I'm going to go ahead and change this to a value that maybe my fan could get to. So let's say about 150 CFM. I want to tell it to go at 150 CFM. So what it should do now, as you can see, it starts increasing the CFM immediately. I'm going to go ahead and speed up my fan so that way, try to get the speed as fast as we can to try to get to that 150 CFM. So I kind of increased it to around 57%. My trend log, I'll probably have to apologize. I'm going to do a little refresh on my screen here just to make sure I get the trend log refreshed here so you can actually see what's going on. And one thing you also should recognize here, I'm running on a web browser using Chrome. All our devices have web services built into them. The graphics is built inside the controller. All the trends, alarms, all the widgets, it's all inside the controller. So I don't have any kind of supervisory layer here from a building automation system that I'm getting access to this VAV box. This makes it obviously very easy for me to demo this and provide you this information. So as you can see here, this is climbing and it's trying to get to that 150. And one of the things I've noticed about this product, which makes it very impressive to me, is it doesn't do a whole lot of overshoot or undershoot. So the algorithm that's running inside this inside this controller, it does an excellent job of understanding where it needs to be, and it starts throttling back the actuator as far as making sure it's going to be very precise to the CFM that you're asking it to be. So as you can see, it's really not opening that fast. It's incrementing in a 0.1 to 0.2%. And we have a feedback, a true feedback that's coming back right now around 30%. And the reason this is very accurate, our controller has a communicating bus that goes to the actuator and the transducer. And it's continuously communicating back and forth. So it's not a discrete input, which many VAV boxes are out there. What I mean by that, it's not a hardwired input. So a transducer is not a hardwired input, or an actuator is not a hardwired input like an analog output. This is truly a communicating device to the two devices, the input devices that it needs to control this valve. And then as far as the algorithm that's running, that's where all the math happens. And that is doing its job to make sure that it's measuring and accurately and is opening the damper position in the right position at the right time to make sure it's not going to overshoot or undershoot. And as you can see right now, I'm about 148.7 CFM and very close to where my set point is. So for the sake of time, I'm going to, let's go ahead and reduce the CFM just a tad, and I'm going to basically override this. I'm going to take it down to 5 CFM. Now, I'm not sure if a lot of people even have seen this before, but 5 CFM, it's a very low CFM. Back to the ASHRAE standards that we talked about, when you're in the unoccupied period, there are standards that's telling all the manufacturers to go to those low CFM. Even though your unit needs to run, provide fresh air into the space, but from a temperature control, the amount of CFM that you would need for your zones, and then as you're calculating all the zones, you have to make sure you have a certain amount of minimum requirement of the CFM. And most of the time, based on those requirements, your CFM has to be very low. A lot of the traditional VAV boxes, they cannot get that low. So basically you have your primary equipment running harder than they should and providing more air in the space than they should. So just if you could think about the amount of energy savings we're talking about right there, or even from a design of a mechanical system, you don't have to we're not paying any kind of penalties of oversizing a unit or undersizing a unit. That is something else to consider based on the disruptiveness of this product that is bringing into the space. Now, it doesn't matter if it's an office space, or if you're in healthcare, or if in obviously in an OR room, or we're talking about schools, retail, warehouses. It's the same from providing the amount of air that's needed at the right time, at the right pressure, at the right efficiency numbers that the energy or the engineers need for their buildings. So as you can see right now, the damper actuator is closing in. Right now we're about 22.1 CFM. It is going to drop, and it's going to continuously drop. And right now about 8.2%, you'll see it going further down. We're at 7.7. My widget here is unfortunately is not working the way I want it to, so I'm going to go ahead and refresh this. It is basically our trend widget. It's a fairly new widget that we added, and I'm seeing some communication issues just with this widget. But as I refresh it, you can see it's definitely dropping. It's trying to trend to this. So right now I'm at 6%, telling me the status feedback of the actuator is about 6.1. It's continuously dropping. I'm at 15.9 right now. And it's going to try to close that damper as far as it can. And it keeps trying it over and over and continuously trying it. But you're not going to see this actuator or the damper just opening and closing, opening and closing. It's not that. It's at very small increments to get to that point. And as it gets to that point, it's going to stay steady. It knows where that damper position needs to be to maintain that CFM that you need. So again, we're at 13.7. It's still dropping. 12.4. Again, I'm actually controlling the airflow here. We're at about 44%. It's probably definitely pushing about 120, maybe 150 CFM through. Obviously, I don't have that in front of me. It's in my basement. It's right below me. I could drop it down a little bit more just to see if it kind of dropped this a little bit faster. And even if I'm doing that, all I'm doing is just slowing the speed of the fan down, and obviously the communication of VAV boxes or the smart air valve to the actual primary equipment. And there's algorithms that are going to be going back and forth, communicating, and then making sure that the ECM motors or the VFD motors, whatever's running inside the primary equipment, is going to react based on the necessary needs of the space for that CFM. So I'm about 2.6 CFM off the set point right now. That is a very, very accurate reading. I've been in this industry for 30 some odd years. I know I may not look like it, but this is by far the most exciting thing I've seen since I've came on board. I'm definitely very excited about a lot of the IoT type of solutions that we have within this deck, but from an HVAC perspective and what we're bundling as this new offering, this is by far is providing me some excitement again to be part of this industry. So again, we're at 6.1 CFM. It is going to continuously drop, and probably within the next 2 to 3 minutes, which obviously I'm not going to take time to do this, it will get to that 5. It'll get as close as it can to that 5. So with that, this was a live demo. I want to go ahead and pause my video right now, and I have just one more thing to show. Okay, we're back again. Hopefully you enjoyed that live demo. I was asked to put this together to make it easier, obviously traveling with restriction with COVID. It's easier just to go ahead and do a COVID. It's easier just to do a live demo like this, and hopefully it's impactful for everybody to see and see what a great product and disruptive product this is. But with that said, there's always one more thing, right? As Steve Jobs said when he came out with the iPhone and all the other things. I'm definitely not Steve Jobs, but there's always one more thing. So with that said, what is that one more thing? We are again in partnership working with our HVAC manufacturing company, that we are now truly looking at an entire system by combining the SACV technology of these smart air valves, and then also introducing the first truly what we call a cube air handling unit, and then what becomes this intelligent air control system. What that means now, this cube air handling unit will have 4 different or 3 different sides, possibly could have 4 sides, that could simultaneously provide heating, cooling, or even neutral air as needed to the space. If you think about the existing technologies around changeover bypass system, VVT systems, those are the type of the system that would really focus around small building environment. Then you had the VRF system came in that really ripped through our industry, and it's continuously doing that. But if you think about those systems, not being as precise from a VVT perspective, and then from the VRF perspective, although it's a very nicely designed system, there's definitely a lot of cost associated with it. Having lots of refrigerant lines moving through, it's definitely not a flex spaces type of a installation. But this particular ITAC system, which what we call, with the combination of the preciseness of the smart air valve, now you truly can control the system with the intelligence of what's going to be inside this cube air handling unit, which is part of the Eclipse controller line, which is called Apex, and the algorithms that's going to be running inside that controller, combination of the VAV controllers that is part of the SACV. We're truly going to maintain not only precise readings from a CFM and temperature, and then be able to simultaneously provide heat and cool whenever is necessary. We actually demonstrated this entire system at ASHRAE this year in 2022. We were running the cube air handling unit at 0.07 inches of static and providing around 500 CFM if needed to about 4 different SACVs, just to give you some understanding what this product can do. So again, just one more thing, that is part of our delivery in the next few months. I don't have the exact date on this, but another thing that this product will kind of increase our capability around being part of this whole IoT infrastructure. It's every single controller that's being used within this ITAC system, being the cube air handling unit and all the SACVs, which is the Eclipse product line. Every single controller has a capability to connect to the cloud. It has a built-in IoT hub connector, or IoT hub relay, what we call it. So straight out of the box, straight out of factory, as long as currently today we only support Microsoft Azure, but we will be supporting all the other clouds very soon. And it's a matter of simple setting on the Azure side and then on the controller side, and the product will start communicating to the cloud, and the data can be collected and aggregated, and you can normalize the data however you want at the cloud level. And this is both get and push, which means bidirectional, And then now you really expanded this product into really a full cloud infrastructure that's needed to be able to manage your entire system and then do the analytics that are needed, not only outside of the building, but also inside the building. So on-premise or outside of premise can be done. So with that, I wanted to at least show that what this product is capable of. And so Smart Air Valve, Smart Air Control Valve, SACV, it is the disruptive product that is being introduced to the market by Disruptive Controls. On top of that, our Eclipse controllers are really enabling all the hardware and equipment controls to be able to create that path that's needed, not only from an ITAC system controlled from a simultaneous heat and cool for small buildings or even mid-sized buildings, or it could be also segregated into multiple sections of a complex building, but also ready into an entire edge, IoT edge device into the cloud infrastructure. So with that, again, my name is Ham Donishment. I am the Director of OEM Sales for Disruptive Controls. I really enjoyed creating this video. I hope you will enjoy it and take away a lot of good information. And if you have any questions, please don't hesitate to give us a contact at Disruptive Controls. And with that, thank you very much. Have a good evening.